Math Analyzers. Welcome to your Chapter 9, Lesson 5 notes, all about sine, cosine, tangent in the unit circles even further because we just haven't talked enough about it yet. It's just so cool and so faceted. There's so many more things we can say. So here's our unit circle yet again. We have this picture on the Lesson 4 notes as well, but it's a really great comprehensive picture of what we kind of are looking at so far. And then we can go back through what are the things we know when it comes to sine, cosine, and tangent of our angles in our triangles. And then as a result, what that means for the coordinates and the points and the sides in the unit circle and resulting triangles. So, quick review. Sine of theta is the opposite over hypotenuse sides in your right triangle. Cosine of theta is your adjacent over your hypotenuse sides in your right triangle. And tangent of theta is the opposite over adjacent sides in your right triangle. So this is your theta. Your opposite side is over here, the y. Your adjacent side is over here, the x. And your hypotenuse side is 1 because this is a unit circle, so your radius is a length of 1. Okay, so that tells me that sine of theta is y over 1, or just y. And then that tells me that cosine of theta is x over 1, or just x. And since tangent of theta is opposite over adjacent, that means tangent is equal to y divided by x. So, as a conclusion, that also means that tangent is sine over cosine. Okay? Since sine is y and cosine is x, then you can represent your coordinate points as cosine theta, comma sine theta. So that's the way we can figure them out, right? These coordinate points are cosine, then sine. And then as a result of all of this stuff, the Pythagorean theorem here would be x squared plus y squared equals 1 squared, right? Which we know since x is cosine theta and y is sine theta, that in the Pythagorean theorem, then we technically have cosine squared theta plus sine squared theta. Those are the squares, by the way. It's the squaring of the function, not the angle measure itself. That's why we put the squared where it is. Okay. The last thing I kind of want to mention is what we started talking about in the last video, which was all about the signs of each of our trig functions in each quadrant. And it all had to do with how we were representing those in each of our quadrants, because x and y are positive here. That also means tangent will be positive here. So sine, cosine, and theta are all positive in quadrant 1. All are positive in quadrant 1. Over in quadrant 2, the only thing that remains positive is our y's because we're above the x-axis, right? But now the x's have gone negative, which means sine is the only one of our trig functions that's positive in quadrant 2. Down in quadrant 3, both sine and cosine are negative, right? Because both x and y are negative. But when you divide a negative number by a negative number, you get a positive number. So tangent is actually positive in quadrant 3. And then come back up to quadrant 4, where your x values are positive again, because we're on this side of the y-axis, right? So now your cosines are back to being positive. So we remember who's positive where by all students take Collins, right? Everyone's positive in quadrant 1. Only sine is positive in quadrant 2. The other ones are negative. Tangent is the only thing positive in quadrant 3. The other ones are negative. And cosine is the only one positive in quadrant 4. All students take Collins. And that's how you can remember who is positive where. Okay, that will also help you when filling in all those values around the unit circle too, right? So we had watched this guy with the black cats video. And so I stole part of his video here just to look at the first quadrant and all of these angle measures, the degree measures equal to the radian measures, and then what are the coordinate points on the outside, the exact values, by the way, of the coordinate points all along the outside of the unit circle. And in this case, just a fourth of the unit circle, just quadrant 1, right? Looking from here to here. Okay. So looking from here to here, 0.10. So remember, that means that the sine of 0, oh, I didn't want theta, I wanted 0. So the sine of 0 degrees is 0 because it's the y value. The cosine of 0 degrees, I just did it again, is 1 because it's your x value. Okay. Up here, it's the opposite for 90, right? And then think about 90, it's going to be 1 over 0. 90 for tangent is undefined, right? So when you put the y value over the x value to make tangent, this is now undefined. Because see, at least down here, the tangent of 0 degrees, oh, I just did it the third time. Holy snot. All right, here we go, is 0 over 1, so it's just 0. And by the way, all this can be checked in your graphing calculator as long as you're in degree mode, which of course, I'm going to double check. Yes, I am. Okay, good. Let me just make this a little bit bigger. So you can see I can check sine of 0 is 0. Cosine of 0 is 1. And tangent of 0 is 0 again. So you can check all that, right, in your graphing calculator. We've even looked at those decimal equivalents. So far, we haven't really learned anything new yet. We just have to continue applying this kind of information that we're taking in. We're taking in so much information when it comes to the unit circle and then all these values around it. So let's just remind ourselves that what's really happening when we've got this angle right here, our reference angle of 30 degrees right here. Okay, what's really happening is I'm dropping an altitude, placing it 90 degrees, creating that right triangle that's a 30, 60, 90 right triangle. And the reason for that is to know what's the x distance from here to here, what's the y distance from here to here, because that gives me the coordinate point here to here. Okay. And again, what we do know about this coordinate point is this 30, right? From here to here, this y over 1, because we know that this side is worth 1, right? Y value over 1 gives me this 1 over 2 if we're talking about the proportionality of 1 radical 3, 2 as the sides. If I know this side is 1, then I take half of that to get this side, this distance right here. Okay. Also, if I know proportionally this side is radical 3, then take half, right? So radical 3 over 2 is the length from here to here. And that's what gets me the x coordinate because that's my adjacent side and my cosine. And so that's how it all comes together. That's where we're getting those coordinate values from. So let's put it into practice, right? Which of the following represents a rational number? Well, for a lot of us, it's easier to think about these radians in terms of degrees, right? So the way to kind of remember radians and degrees for the basic stuff is if your denominator is 60, is 6, then your matching angle measure degrees is 30. If your denominator is 4, your matching reference angle is 45. If your denominator is 3, your matching reference angle is 60. Okay, so now we really can then just look at the numerators to figure out in what quadrant are we, okay? So where are we related to? Now, I will say that I can tell you right now, when you've got the 4s as your denominators, you're always in radical 2 over 2 territory. So cosine of 45 degrees, like this one is going to be radical 2 over 2. This is cosine of what? We're over 180, so 225, right? This is where we get to in quadrant 3, because we're a little over 1 full pi, 5 over 4. So that's into the third quadrant. A lot of times it's really good to just have this. Well, I did a crappy job of putting my center in there, right? But you can see, okay, so you're starting here and you're going to boom here, because this is pi. So this is 5 pi over 4. All right. So we're right here, because this is pi over 2, pi over 3 pi over 4, pi over 4, pi over 4, right? So think of it that way. I know I'm in quadrant 3, so I know that this is going to be negative anyway, because it's cosine, it's negative, but it's negative radical 2 over 2. Okay. And again, because I do know this is 225, I can type these in and just look at that as well. So cosine of 45, right? And of course, just to re-reference, that's radical 2 over 2. So we can re-reference that that is our decimal value. And then let's try cosine of 225. Yep, negative radical 2 over 2, just like I said, right? So those aren't rational. Very obviously not rational. And that makes sense because it's still got a radical involved. So really my only option is having that 1/2 as that special angle. And that results from either a 30 or a 60 degree reference angle, but it depends on what quadrant we're in and what, if we're looking at sine or cosine, because that switches up depending, right? Let me just kind of show you what I'm talking about. That switches up depending, right? For a 60 degree reference angle, cosine is what you would want. Cosine of 60 is 0.5, right? But for a 30 degree reference angle, you want sine of 30 to be 0.5, because those switch off. So when you're thinking about these two, you want to remember this is really sine of 30, which probably answers my question just now. And this is really the sine of, let's see, 2 pi over 3. So there's one third. I'm talking about my whole pi, right? Oh no, my whole pi gets to there. So 1/3, 2/3 right here. So that would be a 60 degree reference angle. So this is really sine of 120. Okay, as a 60 degree reference angle. And you can just check that out real quick, that sine of 30 is going to give you 1/2. There's a rational number. But the sine of 120 is going to give you negative sine in quadrant 2 is positive, my bad. Positive 0.866, right, which we know to be radical 3 over 2. I need to try that again, don't I? How about actually pressing the division sign? That'd be helpful. So that's how I know which one is rational. The other 3 are all irrational numbers. One way to do it, right? Okay. When drawn in standard position, angle beta has a terminal ray that lies in the 3rd quadrant. So let's sketch that. So I can leave my graphing calculator big. Let's sketch that. Angle beta, terminal ray lies in the 3rd quadrant. So let's just do this. Okay. So this is angle beta. it is known that cosine of beta is equal to negative 8 over 17. Well, that makes sense because only tangent is positive over here. Okay, so if I drop my altitude, all right, here's my reference angle right here. So we're talking about this point on the unit circle right here. Okay, we know that cosine of beta is negative 8 over 17. And we know that cosine is the adjacent side divided by the hypotenuse side, right? So what's the hypotenuse equal to? 17. What's the adjacent side from this angle equal to? Negative 8. And I know, right, you're thinking to yourself, oh, you can't have a negative length of a side. We're just talking about where in the quadrants that is. That's the reason we're saying negative. So we're talking about this direction. So adjacent is negative 8, hypotenuse is 17. Basically, if I know my special Pythagorean triples, then I know what this side is. And even if I don't know my Pythagorean triples, to figure out this side, I can plug into the Pythagorean theorem. So 8 squared is 64. 17 squared is 298. So 289. I said that backwards, my bad. 289 minus 64 leaves me with 225. And let's take the square root of 225 to get that missing side. 15, because this is an 8, 15, 17 right triangle. But of course, we know since we are in the third quadrant that that is negative 15. Only the hypotenuse is positive here. Okay, only the hypotenuse is positive here. And that's because negative over negative. That's why we get that particular thing. What do we want to find? Well, I'm going to find what this question wants, which is the value of sine, but I am also going to show you the value of tangent of beta. Okay? So I know that sine is going to be negative because the only thing that's positive in quadrant 3 is tangent. So I know that tangent is actually going to be positive. Now remember that sine is opposite over hypotenuse. So that would be negative 15, which we already have the negative there, over 17. There's the answer to the actual question. Let me just do tangent for you, which would be opposite over adjacent. Sorry, I was just thinking in my head, I already put the plus there, but I want to show you how it gets the plus. Negative over negative gets you that positive 15 over 8. That would be what we're looking for. So we know that tangent has to be positive in quadrant 3. It's really the same stuff we kind of did in lesson 4, but reminders of all the things that we're looking at. Which of the following is equal to sine of 300? Well, let's see if we can see sine of 300 right here. Oh, negative radical 3 over 2. Okay. Well, its reference angle is 60 and it's sine, so that makes sense. We're in the fourth quadrant, so sine will be negative. So we're looking for something that's negative 0.866, right? Following is equal. So let's try them. Sine of 60. Well, we know sine of 30 is 1/2, so that would be, oh, but it's positive. Oh, so wouldn't I just need it to be negative? Negative sine of 60? Right? That should be the right answer. Well, let's just double check it. So negative sine of 60 will give me that same answer that I'm looking for. Let's just make sure that these are not the same, right? So sine of 30, oh wait, isn't that 1/2, 0.5? And negative sine of 30 will give me negative 0.5. So yeah, there we are. Okay, we got it. We got it, right? Because this is negative 0.5 and this is positive 0.5. And over here, this is positive, it's 0.866, but radical 3 over 2. And this is negative 0.866, which is there we go. Checked that on my graphing calculator, right? There's a lot of stuff we can check that way, as long as we recognize those particular decimal values. Now, these are great because this is really what we start applying this unit circle situation to. So these are awesome. The point E is -7, -24. Well, That means it's in the third quadrant because both x and y are negative. And it lies on a circle whose equation is x squared plus y squared equals 625. So that means my center is 0, 0, and my radius is whatever the square root of 625 is, okay? So let's see what that is. That'll be the radius. 25, okay. Oh, 7, 24, 25, Pythagorean triple. If the angle is drawn in standard position and its terminal ray passes through point E, what is the value of sine of this angle? All right. I can do better than that. Like I said, quadrant 3. And we know that because both x and y are negative. So just a quadrant 3. Okay. This is point E. So point E, we're just saying that this angle right here passes through point E on this circle whose center is at 0, 0. Okay, because we don't have anything added or subtracted here in these binomials. And the radius is the square root of 625, which we just learned is 25. So we know that this hypotenuse right here, or this radius right here, is 25 in length. Now, when you drop this altitude here, you have just learned that because this point E is -7, -24, that the x value is -7 and the y value is -24. Obviously not drawn to scale, but you guys get the idea. Okay? So take this triangle and think of this triangle in terms of sine of E, cosine of E, and tangent of E. And what we actually need to know is the sine. But again, I just want to be kind of clear about where we're going with this, right? So sine of this angle is opposite over hypotenuse, -24 over 25. Cosine is adjacent over hypotenuse, -7 over 25. Tangent is opposite over adjacent, which is -24 divided by -7, which of course reduces into 24 over 7. I'm having a fire drill. I'll be right back, guys. Okay, I'm back. Obviously, I could have just stopped it because that was the last question, but still, that was a little crazy. You know, this is how it goes when we're here and in person. So just a few more examples of how we're using all this fun sine, cosine, tangent stuff to figure out those exact coordinates around our unit circle. All right, guys, go ahead, get that homework done. We're going to use these points to help us in lesson 5 and in lesson 6 when we start to take that unit circle and unravel it. I'll see you guys very soon. Have a lovely day. I hope it's as nice out as it just was outside for me. Bye.